Hi guys, welcome back to my YouTube channel, and today I'll be doing the final video of partial fractions. So this is part 3. As I said in my last video, I'm going to be going through when you have 3 factors, because we haven't done that yet. I'm going to be going through when you have one repeated factor. You have to do the questions a bit differently. And then the last one is algebraic division, where you don't have 2 factors on the bottom and you have to represent it as a whole quadratic and a fraction. So first of all, we'll do the first type. So it tells you this is the fraction that you can see there's 3 factors, and we need to give it as it says h of x can be expressed in the form a of x plus 1 plus b of x minus 2 plus c of x plus 5. So this is telling us to express it into 3 instead of 2. So we would start this out as the same as the other ones because it is the same, it's just 3 instead of 2. So if I write that this whole thing is equal to the same as the right side, x minus 2 plus c of x plus 5, then we can compare the numerators. So this, if we cross multiply, we would get a lots of x minus 2 and x plus 5 plus b lots of x plus 1 x plus 5, and then plus c lots of x plus 1 x minus 2. So over here all we've done is when you have fractions, let's say I had 2 over 3 plus 5 over 6 plus 2 over 7, to find the common between all of them, like obviously these don't have a easy to find common denominator, so what you can do is we would multiply the 7 and the 6 by the 2, the 5 by the 3 and the 7, and the 2 by the 3 and 6. So that would make it all have the same denominator. So over here I've just done the same thing. I've just times the other 2 factors by the one we already had. So now comparing coefficients. Over here, this is a bit tricky because we need to expand fully. It's harder to see what makes what. So if I say comparing coefficients, so we have our x squared, our x term, and our normal constant. So to find this, if I expand this out fully, so over here I'm going to expand just to make it easier for us to see so we don't make any mistakes. So if we have a, then we expand this bracket, get x squared plus 3x minus 10. The b would be x squared plus 6x plus 5. The c would be x squared minus x minus 2. So now it's easy to see which term is which. So for our x squared, we would have a plus b plus c. For a minus 12, we would have 3a plus 6b plus c. Minus c, because it's the minus x. And then our minus 26 would be minus 10a plus 5b minus 2c. Okay, now we have our equations. You can do this manually, which is quite long, like getting 2 variables, eliminating one, doing it again to get 2 equations and solving it. Or you can just put it into your calculator. Your calculator should be able to solve 3 simultaneous equations. I'm just going to put this into my calculator to see what I would get. So a plus b plus c equals 2, 3, 6 minus 1, 12, or minus 12, and then minus 10, 5, minus 2, and minus 26. Okay, I got a is equal to 1, b is equal to minus 2, and c is equal to 3. Okay. Yeah, that looks right. Let me just check. Yeah, okay, that's correct. So that's how you do these kind of questions. They're the same as the other ones. It's just an extra step because you get 3 equations instead of 2. So you use the 3 in your calculator, use the 3 equation solver, and your a, b, and c you just replace. So over here your answer would be 1 over x plus 1 plus minus 2 over x minus 2 plus 3 over x plus 5. Okay, that's your first, that's the first question. Can do the second one. Okay, so this one we have repeated factors. So whenever you have a repeated factor, you want to make sure that one of your it actually gives you here, so it's easier. One of your fraction is not the repeated version, just the single. One of them is the repeated version and the other one is any other factor. So let's say you had whatever you have on the top, and on the bottom you have a squared b, where each of these are factors. You would have a over a plus a over a squared, and then the other one is supposed to be b, c over b. So you would have 3 different types instead of 2. So for this one, I can write this out again. This would be equal to, well, I don't have to, it does tell us in the question. Sometimes it don't tell you in the question, so you'll need to work out on your own what the 3 factors are supposed to be. But yeah, okay, that's our 3. Now, so if you write it out to compare numerators, what we need for this one, to get it, we would need an x and an x plus 1, because we already have one of the x's. For the b, we only need the x plus 1 because we already have the x squared, so we don't need the x from this side. And then for the c, we just need the x squared. Okay, now same thing, comparing coefficients. We would have the 3, the 1, and the 1, so the x squared, x and 1. So 3 would be equal to, I can just expand this to make it easier. You'd have x squared plus x, bx plus b, and cx squared. So we would just have a plus c for the 3. For the 1, for the x term, we would have an a b, no c. And for the other one, we would have, so we don't have any a constants, we have a b constant. But that is the only constant we have. So that would just mean that b is equal to 1 instantly. If b is 1, then, well, a has to be 0 because a plus b is 1. And then c, if a is 0, will have to be 3. So those are our answers. If we plug those back in just to... So if a is 0, then we don't write any of this because 0 over anything is 0. So we would just have 1 over x squared plus 3, lots of x plus 1. Yeah, that's it. Okay, so that's our answer for this one. So yeah, same method as before. We just need to make sure when we cross multiply here, we only multiply by what we need. So for example, over on this one, I wouldn't have b lots of this x and this x plus 1 because I already have the x squared. I don't want an x cubed on the top as well as that factor. So yeah, that was the repeated factors. And the last question, algebraic division. So this is when you don't have 2 factors on the bottom. This is whenever you have a top heavy fraction, this is what you have to do. And here we do, because you can see we have a cube term on the top and a linear term on the bottom. So now we'll have to do something called algebraic division, which is just when you divide by a factor. So if I divide by x plus 1, because that's a factor on the bottom, this is the same thing as like bus stop method, the long version of bus stop method. So over here, we compare the first one to the first 2. So we need an x. So we have x cubed plus x squared. We're left with an x squared and we have a 3x as well. So we need another x. So it would leave us with 2x minus 4. And to get 2x, we would have to do plus 2. To get 2x plus 2, which would leave us with minus 6. So our total fraction that we have, how much it totally divides into, is x squared plus x plus 2. And the remainder is just the 6. Like, that's how much it's over. So our final answer would be x squared plus x plus 2 minus 6 over x plus 1, because this was the remainder that we had. This was the remainder we had after we solved it. If this was like a linear one, or if this was something else, we'd have to do partial fraction on this part. But it's just a constant, and we got a constant as a remainder, so it works. So that's our answer for this question, and yeah, that's it for this video. I really appreciate if you like and subscribe. Next video I will be doing, we're done with partial fractions. That's all the things you need to know about partial fractions for now. Next video we'll be doing proof by contradiction, which is also in this topic. We'll go over some of the standard proofs. I think that will be 2 parts as well, because there are a lot of standard proofs you need to know, and like the general idea of how proof by contradiction works. So yeah, thank you for watching, and I'll see you guys in the next video. Bye.